The other type of series that we like to look at is the geometric series. And there's only a very subtle difference between the two. Basically, I've written the same thing down, you'll notice, but just changed a couple of words. Instead of arithmetic series, I've written geometric series. And instead of adding, I've written the word multiplying. So this is where we multiply by a constant amount. And that constant amount we call a ratio, the common ratio, and so we use the symbol R, the pirate letter. So in this case, if I wanted to work out the ratio, yes, I could get the second term divided by the first term. I could get the third term divided by the second term. In fact, I could get any term divided by the one before. It'll tell me the ratio. But once again, I don't need consecutive terms. If I had, I'm trying to remember the same one I did last time. I think I said 5th and 12th, did I? If I had the 5th term and the 12th term, but the difference here, it would be r to the power of 7 would be the ratio because we're multiplying. So I would have gone ratio times ratio times ratio. Of course, the only problem we have with this one is if there's an even number of terms between them. Because if I had r squared was equal to, and say the ratio squared turned out to be 16, is the ratio positive 4 or negative 4? Don't know. So I'd need more information. There actually would be two patterns that might give that possibility. So let's create a general term. First term is a, so the second term then multiply by r. Third term multiply by r again, we get ar squared. Again, we can see the pattern emerging. The general term then must be r. A, and then I've multiplied by that common ratio n minus 1 times. So it's r to the power of n minus 1. And we can ask the same sorts of questions. Well, let's find the ratio in the general term of 2, 8, 32, and so on. Well, it's clear. I mean, we don't really need to do any maths here. We can inspect this one and see that that ratio we're multiplying by is 4 each time. The first term is AR2. So it's AR to the n minus 1. So it'll be 2 times 4 to the power of n minus 1. Now, sometimes we would leave it like this, but in this case I'm not going to, because I could make that a lot tidier, because remember 4 can be rewritten as 2 to the power of something. So if I can make the base the same, I can get a tidier formula. So 4 I could rewrite as 2 squared. Playing with our index laws, we get 2 to the power of 2n minus 2, multiplied by the other 2, I end up with 2 to the power of 2n minus 1. If I can't, let's say that ratio is 3, then I'd just leave it as 2 times 3 to the n minus 1. I mean, I can't play around with the indices there. Same sorts of questions are. Second term is 7, and here's the one I was talking about. Ah, look, they differ by 2. What is the common ratio? Right, so I know, well, look, AR is 7, AR cube's 49, so if I do that division, I'm going to get R squared is 7. So there's actually 2 possibilities for the ratio. Maybe this pattern went 7, 7 root 7, 49, but maybe it went 7 minus 7 root 7, 49. So there's 2 different patterns that would satisfy this one. 1, 4, 16, and so on. Let's see which one of this is going to be greater than 500. So we're going to have to work out a general term. Nice and easy because the first term is 1, so obviously we're multiplying by 4 here. So our pattern is 1 times 4 to the power of n minus 1. Anything times 1, well, I can tidy that one up. So the general term is going to be greater than 500. When is 4 to the power of n minus 1? Now, you could do trial and error with the exponential equations, of course, if they're simple ones. But then remember logarithms. Whenever you want to find the power or the exponent, log both sides, which is simply writing the word log on both sides. Very tricky. But cast your mind back to logarithms, and we will look at logs again later. But we have that rule that says that power we can bring to the front of the log. So I can rewrite log 4 to the power of n minus 1 as n minus 1 times the log of 4. Now I've got an equation I can solve because I can divide by the log 4, and on the right-hand side, I now get about approximately 4.48. Remember, on your calculator, you actually have 2 log buttons. There's one that says log and the one that says ln, which you might have thought was in, but it's actually ln, which is a natural log. Does not matter which button you use,
as long as you use the same one both times. Yep.
You know when you do this equation, is there ever a case when the sign changes?
Yes, that's a good point. What we need to remember is the log of a number between 0 and 1, so think of it as a log of a proper fraction, if you like, is negative. Because a log basically is like a power. It's the index. So if I had 1 over 2, I would have a negative power. So switch the sign. So divide by a log between 0 and 1, then we'd change the inequality sign round.
So what if we had like the weird things where you had 1, negative 416?
Good question. So if you had 1, negative 416, instead of 1, 416, then this question, when they're saying greater than 500, what they're really talking about is the magnitude of the number. Yeah, so they're not really worried about the plus minus. So in that case, I'd just leave the ratio as 4 rather than the negative 4. Yeah. So when is n greater than 5.48, we want the first whole number. So it turns out to be 1024, the sixth term. Okay.